In this video, we will talk about how to determine if a point is on a line. So I have two examples for us to work through here. Let's check out this first example. This question says, is the point 2, 7 on the line y equals 2x plus 3? So to determine if this point is on this line, we can take these x and y coordinates and simply plug them in for x and y in this equation. So we'll plug in a 2 for x and we'll plug in a y for 7, and we're just going to see, do we get a true result? So let's go ahead and do that. So we have 7 is equal to 2 times, instead of x, we're plugging in a 2 for x. So times 2 plus 3. So we have 7 is equal to 2 times 2 is 4 plus 3. So we get 7 is equal to 4 plus 3 is 7. So 7 is equal to 7. So that is a true statement. So we would say that yes, the point 2, 7 does lie on the line y equals 2x plus 3. Now, if you wanted to double check this graphically, you could go ahead and plot the line y equals 2x plus 3. And the easiest way to do that is first plot the y-intercept. So that's the value when x is equal to 0. So we can see if x was equal to 0, we would have 2 times 0, which is 0, plus 3. So y would be equal to 3. In other words, the y-intercept is located at 0, 3. So if we go over here and plot this on this graph, 0, 3, that's right here. And we can see that this line is in the format of y equals mx plus b, where m is the slope. So 2 is the slope of this line. So remember, slope is rise over run. So to plot another point, we could go up 2 and over 1. And we could go up 2 and over 1. And we could just keep going like that. And we could plot a rough sketch of this line, something like this. And we would see that the point 2, 7, so if we identify that point, 1, 2, then we go up 7, 1, 2, 3, 4, 5, 6, 7, that's the point right here. So indeed, it does lie on the line. So that's how you can double check your answer graphically. All right, let's try one more example. This one says, is the point 6, 2 on the line y equals negative 1/3 x minus 1? So again, all we have to do is just plug in a 6 for x and plug in a 2 for y into this equation right here and just see if we get a true result. So let's go ahead and do that. So we'll plug in a 2 for y, so we get 2 is equal to negative 1/3 times x. We said we'll plug in a 6 for x, so times 6, and then minus 1. So when we're multiplying a fraction like this, it helps if we just write the whole number over 1, like this, negative 1/3 times 6 over 1. So if we multiply those values together, if we just multiply the values in the numerator, we get negative 1 times 6, which is negative 6, over 3 times 1, which is 3. So negative 6 divided by 3, that reduces to negative 2. So this whole portion is negative 2, and then we have minus 1. So then on the left-hand side, we still have a 2 is equal to negative 2 minus 1, that's negative 3. So is 2 equal to negative 3? No. So we would say no. The point 6, 2 does not lie on the line y equals negative 1/3 x minus 1. And again, if we wanted to double check that we got the right answer, we could go ahead and plot this line. So let's go ahead and find the y-intercept. So that's when x has a value of 0. This would be 0 times negative 1/3, which is 0, minus 1. So y would be equal to negative 1. In other words, the y-intercept is located at 0, negative 1. So that's right here. And again, we can see this isn't y equals mx plus b format, where m, the slope, is negative 1/3. So that's rise over run. So we go down 1 and then to the right 3 to plot a point. And if we wanted to, we could do it again, go down 1 and to the right 3, right about here. And we could make a rough sketch of this line. And we would see that the point 6, 2, let's see where that is. 1, 2, 3, 4, 5, 6, up 2. That's right about here. That's nowhere close to being on this line. So that confirms that the point does not lie on the line. So those were two different examples of how to determine if a point is on the line. Remember, you can use the algebraic approach like this, or you can use a graphical approach, or you can use both to double check your results.